we have to find force P and Q such that the resultant of the 5 forces PQ and 40 newtons, let me call this as force 1 and 50 newtons as force 2 and 30 newtons as force 3. So the resultant of these 5 forces is 0. So if I write F1 is its x component is 40 cos 60 and y component is 40 sin 60 j cap. That's my F1 bar. F2 bar is entirely along the y-axis, positive y-axis. So F2 bar is 0 I cap plus 50 j cap. F3 bar is along the negative x-axis, so it is minus 30 I cap plus 0 j cap. P bar is along the, so I'll call it as FP bar, which is along the negative y-axis, so it is 0 I cap minus P j cap. And my force Q is at an angle of 20 degrees. The x component of Q is positive, so it is Q cos 20 I cap, but the y component is negative, it is downwards like this. This is my y component of Q. So it is minus Q sin 20 j cap. So this works out to 0.9397 Q I cap minus 0.342 Q j cap. Since the resultant is 0, so I have, if I add all of these, I'll get my FR bar is 0, so implies my x component is 0 and the y component of the resultant is also 0, but the x component of the resultant is, if I add all the 5, so 20 minus 30 is minus 10, so I get it as 0.9397 Q minus 10 is 0. So from here I get Q is equal to 10.6417 newtons. And since the y component is 0, which is, if I add, I'll get 34.64 plus 50 is 84.64 minus P minus 0.342 Q. If I substitute the value of Q, I get P is equal to 81 newtons. So that's the magnitude of force P and Q.